Okay, this is going to be a walkthrough of wave function collapse in Unreal. And as you can see, it generates a grid. The version I have here, it just picks a random tile and collapses it, and then it generates everything from there. It's pretty cool. It's all running in blueprints. A few notes, like I'm not a programmer. This is probably not the most optimized, but that being said, it actually runs pretty well for being in blueprints, and even with a larger file size. Here, let me turn on the other one. So let's run two at the same time. This will probably lag a bit. Where's the other one though? So this one's here, and this one should be here. Let me see why it's not running. Oh, there it is. It's running up in the corner. So as you get bigger, this is going to lose effectiveness. So alright, that being said, for small little grids and kind of understanding wave function collapse, this is going to be okay. So let's get into it. So this is the generator system. There's a lot of debug systems in here, since that's one of the tricky things about wave function collapse, is trying to figure out like what is causing what. So there's a few different components. I'm going to go over kind of the base components, since most of it's in the map generator, and then I'm going to cover the base one. So the first kind of thing that you're going to set up is going to be a tile, and this is just an actor. And in mine, I set up within the construction script. So if we go to the base tile, it's just a plane, that's all it is. And in the construction script, I'm creating a dynamic material instance, and I'm setting the texture to whatever this texture is, which in the class settings, it's going to have two main things. It's going to have the path texture, and it's going to have a list of neighbors for every single side: up neighbors, right, down, and left neighbors. And those are just going to be BP underscore tile variables, and they're going to be arrays. I'm going to quickly go through every tile though. So under blank, these are my neighbors. I set all these up manually. I'm going to figure out how to have this import a CSV file in the future. Here's down left, here's down right, here's horizontal, this is the T intersection, or like an X intersection. This is up left, this is up right, and this is tile vertical. Okay, so these are all the neighbors, and you just use the drop down to select these, because each one of these is simply a parent of the main or a child of the main tile, and that's all these are. And then so there's a separate blueprint for every single tile type, and they all have those neighbors list. Once again, that's probably one of the next things I'll work on, is getting this to read in like a CSV file or something, in order to not have to set up every single rule manually. Okay, so once you have your tile set up, the next thing you're going to need is you're going to need what's called a cell, and it's going to have one function in it, and it's just called create cell, and it's going to have a variable for tile options, which is the exact same BP underscore tile array list. This one's going to be blank, and you're going to keep it blank though, because it's actually going to be filled in at runtime. The other thing this will have is going to have a child actor, and this is just in the center, And you're going to, when instead of spawning in, I'm just putting something into this child actor. I don't know if that's actually more efficient, but I think updating a child actor seems more efficient than spawning in a new actor, so that's why I did it this way. And then force random gen, this is just a debug. You don't actually need this to run. I put this here, and basically when debugging the first part, I guess I'll jump into the map generator. If I'm going to disconnect this real quick, you can check that and just be like, hey, is my grid spawning right? Like, dude, is all the stuff at the start working correctly? And it's a great way to just check it, and it just throws in a random tile into every single thing. So I found that quite helpful to debug. And all this does is, if that's true, just set the child actor to some random thing that has been put into the tile options. But it's not actually necessary. The other two variables that aren't actually used, but you need the variables in this tile or the cell, and you need these variables in the cell. The tiles and cells are different. I get the terminology confused, but there is a distinct difference. Cells are the thing that fills the entire grid, and then a tile is what we're calling each specific shape. So whether it be a T-intersection, vertical line, or whatever. And the other two variables in the cell is a collapse variable, which will be set to false to start, and then ready to propagate, which will also be set to false at the start. The tile options is instance editable. I think these, you might, they don't actually need to be instance editable, but maybe they do. It seems to work though without it. The other little thing, make an enum just with an up, right, down, and left direction. This will be used in the map generator only in one spot though, so and you'll see where it gets used. All right, so now let's get to the meat of things, which is the map generator. This is anything marked with pink or purple is like a debug system. It's not really necessary. I just have them. I'll probably explain them because you might need them when you're making yours. But so the first one, I just have an not activate, so I can turn things on and off. And I don't need to delete actors, and I can leave them in place. In terms of variables, there's going to be dimensions. I set this one to 5. Cell size. This is how many update without collapse stop. So this is used down here, and it's basically, it's going to try to propagate entropy, what they call it in wave function collapse. And if nothing collapses within a certain cycle of propagating entropy, it will stop. So that's just to stop your algorithm from running indefinitely. With this simple tile set, 2 seems to work pretty well. But if you had a more complex tile set with a more complex rule set, you might need something more complex. Lastly, tile options. This you will fill out, and you're just going to put every single tile option in your tile options. This is instance editable. Then the last variables you need is some grid components. This is going to be every cell in your grid will get dumped into this list. Tile reference objects. This is a weird quirk of Unreal, a workaround. I'm certain there's a better way to do this, but the way I'm using this, so I spawn one tile like really far down, and I hide them and turn off their collision. And the reason I have this, let me see if I can find. So when you update the generation, you can't actually get a variable from a class, at least not in blueprints, not any ways I can find, but you can get a variable from an object. So in order to get the neighbors, I grab from the tiles that are already spawned in, and I only need one of each type, and then I get the neighbors of the type that of the class I'm looking for. So it's kind of a roundabout way to do it, but it does seem to work. This was actually one of the harder things to figure out on how to get it to work in blueprints. So that's the other tile reference object. And then lastly, there's a Boolean, which is marked none, which is continue. And that is kind of an optimization. There's like a little gate here, which basically, trying to remember, this will, if anything collapses, or if nothing collapses, then you're going to continue, I think. Let's see here. So this will go into this. You set continue as false, and then you go through all the grid, and if there's still tiles that haven't been collapsed, that's what it's checking for. If there's still tiles that haven't been collapsed, then you're going to continue. But if all tiles have been collapsed, then this will be marked as false, in which case your algorithm's done. You don't need to collapse anything else if everything has already been collapsed. So that's what that system is for. And those are all the variables you need in the main system. There is quite a few functions, but we will get to those. So I'm just going to progress through this chronologically in terms of the way it will activate, and we will go from there. So let's just run it real quick. We have random generation on. So let's turn that off, and we are going to hook this back up, and then we are going to run it, and there it goes. See, it picked a random one, and then it's just filling it out based on entropy and whatever rule set it's using. Okay, so the system starts on begin play. This is just a switch basically, and it was like, hey, is it allowed to run? Yes, it's allowed to run. Okay, so the first thing that happens is we spawn in these reference objects. I'm paranoid, so I clear the list. You probably don't need to. And then I'm just going to run a loop for all the types of tile objects, and I'm going to spawn in one version of every one of these tile objects, and I'm just going to spawn them, what is that, 100,000 units down, and I'm always going to spawn them in. I'm going to ignore collisions, and I'm going to add these into a list. I think add will work here, but I'm using add unique, and then I'm going to set the actors as hidden, and I'm going to disable their collision. And these is just so we have the tile reference object. The main part is I'm going to clear the array. Once again, I probably don't need to clear this, but paranoid. And then I'm going to initialize the grid. This is where it really gets started. So we're making a grid, so we want the dimensions, but since this starts at 0, we want to subtract 1 because we're counting 0 gets counted. So you want to subtract 1 from your dimensions, and you're going to loop through that for the y, functionally speaking, and then this is going to be the x-axis on the grid, because you're going to loop through this on a loop, and it's going to be the exact same thing. And this is the cell size here, which I am multiplying by the index to get how where it needs to be placed, because you want it to be placed, if it's 0, if both these are 0, you want to be placed at 0. If this is 0 but this is like 1, then you want it to be placed one cell size like to the right. So if it's 400, you want the next cell to be placed 400 to the right. So that's how it gets kind of pushed. And then the scale, you're going to take the cell size, since these tiles are 100. If you look at the plane here, this is approximate size 100 units by 100 units. So the cell size, you're going to divide it by 100. Make sure this is a float though. You don't want to divide the integer because fractions will do matter for the scale. And you're going to put that into the scale, I also wanted mine to be like movable. So you notice like I can flip this around and change where it starts. So let's turn that one off, turn that one on. This will lag probably. So it actually moves relative. So you notice I could kind of like rotate it 90 and I can put this wherever I want. So that's what this is right here. The transform location, I'm just transforming it by wherever the actor's location is because I want this location to be relative to this. And then the actor rotation, you can just put in there. So it's the correct rotation. And then whenever a cell spawns, you're going to run this, the create cell script, which is all it's doing is filling in the tile options, which at the start is going to be every single tile. And then every single thing that's spawned, you're throwing into the grid components array and adding here. You can probably use add unique. Why not? Someone, if add unique is bad to use here, let me know. This was just a simple debug system right here. I forgot. I was getting some weird numbers and I realized I wasn't subtracting one from my dimensions, and I used this to debug it. Like how many tiles am I actually spawning in? So that's what I did. I just did it like that to be like, what's actually going on here? Okay, so now that once this is all complete, you've spawned in all your cells, you collapse the first cell. Some of these functions, I will say, have kind of similar functionality, like similar things will be happening in them. So here we're just grabbing a random cell. We want to save it as a variable. You don't want to like hook this up to like this, like all these, like, oh yeah, just grab the random cell, because then it will grab a new random cell every time it gets referenced, and which is bad. You want a random cell, but you want the same random cell. So I save it as a local variable right here, which is just a BP cell. And then there's going to, or no, that's the temp grid. Is this actually being used? No, it's not. You need the random cell, and then you need the random tile, which will be used later. So first thing you want to check, like, hey, only do this if it's not collapsed. And then if it's not collapsed, go ahead and set it to be collapsed. Set it to be ready to propagate. This is the other variable. This is used mostly as an optimization. You can technically run it without this optimization. And then it just picks a random option within that cell. So one of these options, which will be filled in by any of these options. And it's just collapses it, right? And then it says, go ahead and remove all the options other than the one you just picked, which is this one. And go ahead and add that to its options after you clear the list, which is important because you don't want other things options to be if it's already collapsed. And then this is spawning in the tile essentially, but since we have a child actor, we are just setting the child actor to be whatever we picked as the random tile. And that is collapsing the first cell. There's a note here. This doesn't technically have to be random. If you want to like weight something as like the first cell, you could, there's probably a way to like weight this instead of them just picking randomly. Okay, we're going down to the actual kind of meat of the algorithm. So we collapse the first cell. I go ahead and jump into my delay. You could probably start generating right away, but it's already run all this stuff, so I feel like I want to give it a break. I'm going to explain this debug real quick. I sometimes hook this into here to see that this was mostly to debug the sorting list right here. Sort by least options, where instead of filling all the tile options for every tile, this just, each one of these has a different number of options in it. You can see and I'm just filling each tile with a random number of options because I wanted to see if this was sorting things correctly. So that's why that was there. It doesn't, that's all it does. Okay, so after we wait, we jump to the start of the algorithm. This is a good time to note that the wave function collapse is more of an idea than a specific code set. So that's what we're doing here. So we're removing the collapsed cells. So let's go through the grid. And this says, hey, don't include cells that like still have all their options. Like, we don't need to check those, and we don't want to include those onto this list we're about to output, since we're going to output a kind of a pruned list of the cells we actually want to check and propagate. But we don't include things that haven't been touched at all. Go ahead and remove those from the grid, and remove any cells that have already been collapsed, since we don't need to mess with those. We only want the cells that have a lower entropy than max, but we also don't want cells that have already been collapsed. This is just kind of a check. This technically shouldn't fire, but it fired quite a bit when I was making this, so that's why it's here. It doesn't fire anymore, but this just says like, hey, remove any cells that have no tile options. But this is only cells that have 0 tile options and have not been collapsed. So this is basically your algorithm has failed if this is firing. Something is going wrong. So I hook up a debug, hey, warning, removing collapsed cells with no tile options. That means your rule set is too complex, or maybe that run through, it just like, it didn't work. And this is just a debugger to see if things are getting removed correctly. You could also put systems here to, excuse me. Okay, you can also put, there's plenty of optimizations you have here to like remove untouched cells, which we're actually doing. So cool, we implemented that. Though you would need a fail-safe to make sure it doesn't get stuck, which we are kind of doing as well. So let's delete that. Let's jump back to the system. So we exit with this pruned grid, and let's just check the length and be like, hey, is there anything in this pruned list? And if there is, we're going to do stuff. However, if there's not, go ahead and bypass these 2 cells and then jump to make sure, hey, is there still things that are uncollapsed? This was kind of the system we explained earlier, where it's just like, is there still cells? Are there still cells that are uncollapsed? If there's any cells that aren't collapsed at all, go ahead and mark it as continue, and then update another generation. But just to make sure it doesn't do that indefinitely, there is a do and kind of check here. And if this exceeds the counter number, then go ahead and output a warning, stop the system, and output, hey, exceeded the number of updates without progress. Okay. But assuming there's some, let's say there is stuff actually on the list though, which is, that's what this system is for. Is the cell list getting sorted in the output and outputted correctly? Which I'm just feeding in the list, and then you can run this. Hey, is there anything on this? Hey, there's nothing in the array. Or we kind of grab the length to figure out how many tile options are in each section of the list and what are the actual cell names to figure out like what is actually getting outputted by each of these systems. So then we are going to sort by least options. So this is a sorting function. So we are inputting the grid, which is, this will be the pruned list. So this is going to be the shorter list. And we are going to go through we can grab the current cell, the current stepper array, and it's like if there's nothing in this original, since we have a local function here, or local variable, which is the sorting list, it's going to say, hey, if there's nothing in the sorting list, go ahead and just throw something in it, and just throw the current cell in there, just so we can get started. Okay, so that will this always will happen the first time it runs. And the second time, it's like, okay, there is something in the list. Let's go through. Let's grab the length, so how many tile options are in that cell. And let's save it as a variable. And then what it's asking is like, if the current array is less than the one before it, go ahead and put it before, insert it above the stepper. Since this is going to, because if it's not, you're going to decrease the current array stepper, and you're going to move up or down through the list, so to speak, until you get to the start, to always put the lowest length cells, so it's the thing with the lowest entropy or least tile options at the start of the list. So it's always going to, whatever, if it's ever less, it will move it until it's not less, and then it will put it in that part of the array, which is what we want. And then there is a few little checks here. If the array stepper is 0, just put it at 0. Like you can't, it will, with this, the way this is set up, it will try to put it at -1 if this isn't here, which it can't do, which won't break anything, but will give you a warning. And if it's greater, if this is greater than 0, then subtract 1. If not, just use 0. This is to prevent it from trying to access anything at an index of -1. It's like, look, if you're trying to find something before 0, just whatever's at 0 will be fine, and that works. So that's what happens there. This is just sorting the system to output the list. This will be the same list that goes in, but it will be just sorted to have the option with the least options first. In which case, now that we have that list, we can just dump it and just grab whatever's first, right? Because that's going to be the least option, and we can just collapse it. And this is very similar to what we did here. This is actually copied from the other one. So we're just doing all the same things we do. It is a different function though. You can't just reuse it, since it does do a few different things. But it's going to do a lot of the very similar things, where it's just going to grab it. Hey, if it's not collapsed, go ahead and collapse it. Set it ready to propagate. Pick a random option. If this is the least, it's going to be less options than normal. Go ahead and collapse it. Do the same thing where remove all the options other than the one you collapsed and add that as a thing, and then set whatever you picked as the child actor. So spawning it in. And then here I also remove what you just collapsed from this list. The reason this might be a little confusing, because we have an entire node to remove cells. Why remove it here? And that is just, it was initially so we can check to see if there's anything left to collapse, but now we are using this. So this is actually not needed. I'm almost certain. I'm going to delete this. And I'm going to move this up. And I'm going to remove that. If you're not using this system, you can check this array, but you don't actually need it. Cool. So we don't need to output this temp grid even, which means I think we can probably do, I'm going to change this. I have a backed up version of this, so I'm not, that's why I'm kind of okay. So this is kind of a simpler version. So see this, I was checking, hey, is there anything left to collapse? But that's when I was running this system on every single tile. So that's where this is useful. But in the new system, I don't think we actually need this. And I don't think we need this, by the way. Shift delete, by the way, leads the... How? I don't think we even need that. Let's see. Did I just break it? I think this simplification might work. Let us see. Seems to work. Does it finish? Very nice. Okay, yeah. So yeah, this was all that was from the previous version where we were checking the length to see if we should continue, but we're not doing that anymore. Now we're checking to see if everything is collapsed like this, which means we don't need that. Very cool. Okay. So then we check, hey, is there anything in the grid that isn't collapsed? If there is, go ahead and continue. And we are going to update generations. All right. Let me show local variables. We're going to need index and then a y and x chord. We're just going through the grid here. And we are checking like, hey, only run all of this mess on things that are actually ready to propagate. Like, we're going to go through the entire grid. However, only actually run the full kind of propagation system if the tile is actually ready to propagate. We'll check every tile, but we're not going to run the system on things. And then after we propagate it, things only need to propagate once. Once it's any particular cell has propagated its entropy, then you're good. It might get remarked to propagate, which is totally fine. But if it has propagated what it's supposed to, go ahead and turn off ready to propagate. Or this will stay fully closed once it's collapsed. And here's the actual entropy system. This is kind of what people think of when they think of wave function collapse. And this is what I interpreted from the Unity video. So we're going to look up. And the reason we look up is, hey, don't check if there's nothing above the row. If you're at the very top of the grid, you don't need to run this. Same with all of these. Hey, if you're at the rightmost column, you don't need to look to the right. If you're at the bottom, you don't need to look to the bottom. And if you're at the left, you don't need to look to the left. And then, however, if you're not at the top, grab the index of the grid that's above the tile. And that is going to be true for all of these. The equation is slightly different for each of them, but it's grab the index to the right, grab the index below, grab the index to the left. This is where the enum comes in, by the way, is this compare cell, is we can check this. Okay, for up, right, down, left, compare cells. And this is kind of the last part. All we need here is, so the primary cells, let me show, I'm going to use a list here. This is a set, which is actually one of the few, I don't use sets often, but this is actually a good use case for a set. So we get the primary cell index, the adjacent cell index, and the direction, which if we look in the propagation, update generation, this is the main index, which is what we generated here, saved as the index. And then the adjacent cell, which is the equation, and then we just kind of mark what we're doing because we'll need that to know which neighbors to check for. So get the tile options from the primary cell. So that's this weird thing where we need to use the tile reference objects. And we're just going to dump every neighbor for that direction, for every option, into a set. And then after we get that, we are going to check the adjacent cell and trim out anything that's not in the neighbors. It can be in any of the neighbors, but if it's not in any of the possible neighbor options, then go ahead and remove it from the option. And if anything gets removed from its tile options, if anything at all gets removed from it, set it as ready to propagate, because that means the entropy has decreased and it needs to be propagated again. But that is the system. So, and then that gets done for every direction for any cell that's ready to propagate. And that's how you set up wave function collapse in Blueprints. Again, I'm going to try to get this to work in 3D and see if you can get it to input CSV files. But other than that, y'all have fun.